In previous problems, we've had to determine the limit of a rational function like this, where we saw by direct substitution that we have a limit that's in the form of 0 over 0. However, we could use the property that when the top and the bottom can be factored and simplified, we can use the simpler function to evaluate the limit. In this case, the limit is 2. What happens when we are faced with a limit that is indeterminate in the form such as this, 0 over 0, but the limit does not factor and simplify like we would like? Well, we have L'Hopital's rule. This is a theorem which allows us to deal with indeterminate limits of form 0 over 0 or infinity over infinity. When we have these types of limits and we have differentiable functions f and g, then the limit of f of x over g of x as x approaches a is equal to the limit of f prime of x over g prime of x as x approaches a, only when the limit is in 0 over 0 or infinity over infinity form. So, back to our sine x over x as x approaches 0 example. Since this is in the correct form of 0 over 0, we could apply L'Hopital's rule, and I'm going to make note of it right here. Taking the limit of the top function, taking the derivative of the bottom function, we now have a limit. We can use direct substitution. Cosine of 0 is 1, 0, and now we have a limit.